Hey guys, how's it going? Welcome to the part 8 of Python Pandas tutorial series. When you load data into Pandas data frame object, you will see in real life there is a lot many information which is missing and there are some information which is duplicate in nature. In this section, we will talk about how to deal with this missing and duplicate data in Pandas data frame object. So without any further delay, let's get started. So first we need to identify whether the data is missing in the data frame or not. For this, pandas provide two main method, which is isNA and notNA function or method, with which you can um, identify the missing information. So here we have importing pandas and numpy, and here I'm creating a pandas data frame object which has 4 rows and 5 columns, and the column names are 1, 2, 3, 4 and 5 respectively. Then in this part, I'm randomly selecting uh, or subsetting the data frame by index, which is by iloc method, which we have seen in the previous tutorial, and then assigning the nan value to them. And this is how the data frame look like. Now, the first thing we would do is to identify the missing information, and for that I'm going to use sum method. Okay, sum. We will talk about isNA and notNA in a minute, but first let's see how we can identify nan information by using sum method. And here I'm saying df dot sum method. Then here I'm saying axis is equal to 0. So I'm looking for column by sum. And then here I will explicitly say skip NA equal to false. By default it is true, but I'm explicitly saying give me don't ignore the NA value. Now if I will just go ahead and run it, you will see as we have in this data frame column number 2, column 2, 3, 4 has nan value. That's why when you do the sum method or perform the sum method on the data frame without using skip NA equal to false, you get nan as an output for against column 2, 3 and 4, and in a way you understand, okay, there is some kind of missing information is present. Now let's look how to use this isNA method. Now here I will say def dot isNA, and here I will open and close parenthesis. Now first let's run this one and we will see what it does. So basically it will test this method, isNA method, against each element of the data frame, and that's what you get. Now to narrow down further, you can use sum, and here says sum axis is equal to 0, and if you run this one, you get column 2, 3 and 4 has value 1, 2, 2. That means column 2 has 1 NA value, and column 2 has 1 NA value, and column 3 and 4 has 2 NA value respectively. Other way you can use, or alternatively you can use any and all, which we will see here. Let's say you say df dot isNA, and then you say any, and let me first run this one, you will see the output. So this is what it look like. So what it's saying, column 2, 3, 4 has nan value. This any method is more, you can relate as end value. So if any of the element within a series or a column is true, it will return true, otherwise false. Similarly, I can use, let me create another block here, and here I will say use df dot not na, and if I will just go ahead and run it, you will see it is doing exactly opposite of na, isNA. Now to know whether there is a NA value exist in a column or not, you can use all method, and this will act as a OR condition. So if all the elements of a series is true, then it will return true. otherwise false. So in the column 2, 3, 4, one or many element has true, the value, the not NA value is true. So that's why it's not NA value is false. That's why it's returning false. So now though we have seen how to identify the missing information within the data frame, the next step is to fill this missing information with some value. And for that we will use fill_na method, and this will fill the nan value with some value which we will provide as an argument to this function. So let's let's see the example here. What we're gonna do, we will say df dot, we will grab this fill_na method, and here we will pass, let's say 0. So what I'm saying, fill all the NA value of a data frame with the value 0. Now if I will just go ahead and run it, it will return a data frame which where the nan value is filled with 0. You can see that one. So if I will just say print df here, you will say the nan value is not filled actually. So this particular method ensure that it will return a data frame where nan value is replaced with some value which we have provided here as argument. If you want to explicitly say that fill NA and also uh, don't return the data frame but rather do it in the same data frame, then you have to explicitly mention in place equal to true. So in that way uh, it will replace the fill NA value and also will do the same operation in the same data frame. Okay. You can also provide any other argument. Let's say if you want to provide df.fill fill na, and here you say missing, because this is a string argument, uh, missing, then the resulting data frame will be uh, okay, we have already in place it, that's why there is no more nan value. Otherwise you can see the missing uh, the this string value will replace where you will get the NA value within the data frame. Otherwise let's create only, let's again paste this thing, uh, and here you can see the new data frame is created where the nan, where you have a nan value within the data frame, it is now being replaced with the string value missing. Okay, now the next thing which we will talk about is fill gap forward or backward. So you can also propagate non-NA value forward or backward, which we will see here. It is forward. So whichever you will find in the first element. Now I'm asking this by using this fill in a method pad. I'm asking this data frame to fill the above value of the series. Okay. If you only want consecutive gap filled of to a certain number of a data point, then you have to explicitly mention a limit keyword. Now here we will see the example. We will just do the same thing. We have explicitly mentioned that limit is equal to 1. It is, we are doing the padding forward only, but we are keeping the limit 1. Hopefully it is intuitive. So here we can use ffill or forward fill instead of pad, because here we are doing forward filling. If you want to do the backward filling, you have to mention uh, bfill or backward fill or backfill. You can also fill NA using dictionary or series that is aligned to the data frame of the series, and the label of the dictionary or index of the series must match the column of the frame you wish to fill. The use case of this is to fill data frame with a mean of a column. So let's see the example here. Uh, df dot mean. So this will return the mean object, the mean of data frame column wise. You can also explicitly pass x is equal to 0, but by default x is equal to 0. That's why you are getting this one. Now we want to fill the data frame using this pandas object. So here I will see df dot fill na, and here within the argument, within the fill na, we will pass this argument df. Cool. So now you will see where you have the missing information. For example, in column 2, row number 1, this is now is being filled with the mean value, okay, which is 9.33 uh, for column 2. Similarly, you can also interpolate or you can fill the missing data with interpolation. Both series and data frame object has this interpolate method with which you can do that. It actually interpolate between column. For example, in column 2, the missing value is in the row number 1. Now this is being replaced with the interpolate value 1 and 11, which is 1 plus 11 by 2, which is 6. That's why you are getting 6 here. Similarly, you can also calculate the similar thing in column 3 and 4. Okay, cool. You can also provide method argument which gives access to a fancier interpolation method. But the one which we will do here is called a chemia. You may wish to simply exclude labels from a dataset which refers to missing data. To do this, you can use drop na method. So here we will say df dot drop na, and first let's pass the argument x is equal to 0. So if I will just go ahead and run this one, you will see you exclude all the um, rows which has NA value. Similarly, if you want to exclude uh, all the columns which has NA value, you can use drop NA, and here instead of x is equal to 0, you can say x is equal to 1, and then here I will say just print new line. It will look nicer. I forgot to print here, right? So putting the print statement. Now if I'll just go ahead and run it, you will see when I provide x is equal to 1, you get only the columns which has all the value in it. Okay. Similarly, when I say x is equal to 0, it only providing me the rows which has no none value in it. Sometime we may need to remove duplicate entries. In pandas, both series and data frame object has this drop duplicates method which allow us to do so. So we will see the example here. Let me create a data frame here, and then I'm just creating this duplicate values in column of number 4 and sorry, the row number 4 and column number 2. So if I will just go ahead and run it, you see this is what I'm saying. Okay. Um, it has a duplicate value which is 1, which is similar to the column 2 element number 1. Okay. Now if I will just simply say drop under sorry df dot drop duplicates, oops, df dot drop duplicates, and then simply say run. Now why it is giving the same result only? It's because even though column 2 has a duplicate entries which is index 0 and 3, overall each row of this data frame is unique. Hence drop duplicate method fails to perform any action. If you want to remove duplicate from specific columns, then you need to pass the same column name as a subset argument to the duplicate method. So here I will just do the same thing, and and within the argument I will say subset is equal to, here I will pass the column name, which is 2. Now if I will just go ahead and run it, you will see now the duplicate entries is removed. Okay, there is only one value in column 2. So that's all for today's tutorial. In the next tutorial we will see how you can apply a UDF function or user defined function element wise to the pandas data frame object. As usual, if you have any question, please feel free to drop your questions comment in the comment section, or else thanks for watching this video. Until next time, cheers.